Welcome back to my channel. Angular's dependency injection system is incredibly flexible, but with flexibility often comes complexity. It's easy to get confused about how Angular resolves dependencies across the injector hierarchy. And let's be honest, Angular's documentation isn't always being friendly. That's why in today's lesson, I'm going to walk you through how Angular handles dependency resolution across its injector hierarchy, step by step in a clear and understandable way. In the second half of the video, I will get hands-on with a lab session, so feel free to repeat the steps with me. My name is Maxim Grom, and this channel is about web development. Let's dive in. Last time, we looked at this UML diagram. It highlights a key point. Before Angular can inject a dependency, we must first provide it. But what happens if the injector has no information about the requested dependency? Typically, your application includes at least two fallback injectors, the platform injector and the NullInjector. These are called environmental injectors. You have probably seen services provided using providing platform. This makes them available across all Angular applications. The NullInjector is Angular's final stop. It throws an error if the dependency is required, or returns null if the injector is marked optional. What is optional injection? I will cover that in the upcoming video. Next up, the app component element injector. Yes, every component has its own injector. Actually, it has two. One on the host element and one inside the view of the component. Both are technically element injectors, but exist at different levels. To better understand this, let's look at the component decorator interface. Angular's interfaces are very descriptive. Let's take a look on component decorator first. In the component decorator, we find the viewProviders property. This allows us to configure providers specifically for the view. The component decorator extends the directive decorator. If we check directive, we see the providers property. This one configures providers on the host element. Directives don't have a viewProviders property, only components do. We will experiment with this during the lab. Let's go back to the UML diagram. You might think that's everything, but if you understand recursion, now is a good time to visualize how deep a component tree can go, and how each component can introduce its own pair of injectors. And don't forget, directives can also exist at any level in that tree. Is that full story? Still no. Angular also supports lazy loaded roads. For example, if a user navigates to a login page, Angular loads a separate bundle for that feature. What does it mean for dependency injection? Angular creates a new environment injector for the lazy loaded feature. This injector is placed between the parent environmental injector, typically the root injector, and the app components injector. And yes, components in lazy features get their own two injectors, just like regular components. You can even nest lazy features with lazy features. In the second part of the video, we will explore this live in an Angular application. If it feels confusing at first, that's okay. Watch it again as needed. Before we jump into the lab, let's understand how Angular resolves services in the hierarchy. In the next UML diagram, circles represent where services are provided. Diamonds show where services are injected. In our example, Service 1 is injected into a feature component. Service 1 depends on Service 2 and Service 3. Service 1 is provided in the app component view injector. Service 2 and Service 3 are provided in root. Here is how Angular resolves this. Step 1. Check the feature components injector for Service 1. If it's not there, move to the parent level. Step 2. Once found, Angular uses this injector to initiate Service 1. Step 3. Angular looks at Service 1's dependencies, Service 2 and Service 3. Step 4. To resolve S2, Angular starts from the app component viewInjector and walks up the tree until it finds Service 2, in our case at the root level. Step 5. Angular repeats this for Service 3. It will also start from app component viewElementInjector and walks up the tree. Once all dependencies are resolved, Angular creates Service 1, stores it in the injector, and returns it to the feature component. Why is it important? Let's simulate a mistake. Let's say you decide to provide a Service 1 at the platform level to share it across 5 applications and improve performance. Month later, you add dependencies Service 2 and Service 3 to the Service 1. When Service 1 is injected in the feature component, Angular walks up the hierarchy, ending at the platform injector. It tries to initiate Service 1, but can't resolve Service 2 because it doesn't exist in the platform injector. Angular doesn't go back down to find the dependencies, it only goes up. The next step is a NullInjector, and you get an error. So here is a rule. Dependencies must be provided at the same or a higher level than the service. Another takeaway from the UML. For micro-optimization, try to provide related services at the same level. If Service 1 is provided at root, Angular only walks up once to resolve all its dependencies. If Service 1 is at feature level, Angular walks up multiple times, once for each dependency. But don't overthink it. Just try to provide as many services as possible in root or at the environment level. One more thing, lazy feature environment injectors cannot override component level providers. That's why I prefer keeping most services at the environment level. I only use element level providers when truly necessary. Before the lab, let's discuss one last tool, makeEnvironmentProviders. Angular gives us two types of injector, environment and element. With makeEnvironmentProviders, you ensure services are bound only to environment-level injectors. It prevents accidental providing at the element level. Let's go to the fun part, practice. We will create a simple service that provides an emoji and override it at different levels. You see, we have a service with one property, emoji. To make it dynamic, we will create a utility function that returns a factory provider with a different emoji. I added a list of emojis to make it easy to test. At first step, let's provide emoji service at the root level. Now it's on the root level. Second step, inject it into a component and display the emoji. It works. I rendered emoji from emoji service and of course injected it. Can the app component override the root level provider? Let's check. And yes, it can. Angular checks injector in the order view, host, root, platform, and null. App component's view provider can override root provider. Now we see Christmas tree instead of ghost. Why do we need two levels of providers? To explain it, we will create a simple emoji component that renders the component from emoji service. I have app emoji, which inject emoji service and extract emoji to emoji property of component. Let's use it in template. Also, I need a wrapper component. A wrapper component with different view providers and provider, with octopus on view provider and robot on provider. And wrapper renders emoji component inside it. Let's render wrapper component in app component. So I imported wrapper component and rendered it here. And we have expected result. The emoji component rendered octopus instead of robot. But wait, Angular lets us place component inside other component using ngContent. Let's go to the wrapper. Now we can put one more component between the tags. I need emoji component here. In app component, I put app emoji inside app wrapper, and let's check what we have. We have octopus and we have robot. If we pass emoji component as projected content, it uses the robot emoji again. Why? viewProviders affects only the component's own template. Providers affects both template and the projected content. Now it makes sense. Let's make things more interesting. Add a directive. The only purpose of this directive provide a frog emoji. Let's add it to the app component and attach it to the wrapper's host. Now what happens? The component and directive share the same host, the wrapper element. And since the directive is applied after the component, it overrides the emoji. This shows how powerful and flexible directives can be. You will see this pattern in libraries like Reactive Forms and Angular Material. Not only components and their host can have injectors. Every HTML tag has an injector. Let's go into wrapper component. I added one more app emoji and added tag P around it and added tag app frog. Now the paragraph tag has its own injector and the frog emoji overrides the octopus. Are you still with me? Let's test this in lazy loaded roads. We need app roads file. We can define road level provider. As usual, let's check the Angular interface first. Let me jump into the road definition. Angular's road interface includes a providers property that creates a new environment injector. Let's test this. We will use non-lazy road and we will use a lazy road. To test it, I need one more component. Let's call it zoo component. So zoo component just render emoji component. With this configuration, I expect to see Christmas tree. Zoo works and we see Christmas tree. Now I'm going to add providers. Let's check. I see a Christmas tree instead of monkey. If you provide the emoji at road level, it overrides the root, but not a component level providers. Now remove the app component provider. The monkey emoji appears perfect. You see how practice aligns with theory. Nice. And the last step, let's make the road lazy. I provided zoo component as lazy component, and no difference here. The monkey stays on screen. I hope you enjoyed with the practice session. Let's summarize the video. Angular has two types of injectors, environment and element. Environment injectors come first in the hierarchy. makeEnvironmentProviders ensures a provider is limited to the environment level. Every component has two element injectors, one for its host, providers, one for its viewProviders. Directives only use the host injector. Angular resolves dependencies by walking up the tree until it finds the provider. All dependencies must be provided at the same or a higher level. For best results, provide services at the root or environment level. Use element level providers only when necessary. Thank you for watching this playlist. See you in the next lesson. Bye.